Hello, this is the last video about crank slider mechanism, and we have all the components done and we can start to do the assembly modeling. But before that, I want to talk about two different things. Of course, the appearance, will add them, but the most important thing is to think about 3D modeling the model. Okay, so I want to use as less material as I can. For example, in this example, so I have the connection rod, I have the crank, the slider, but as you can see, the holder is using a lot of material and it doesn't need to. So let's find a solution to reduce the material so it will reduce the printing time and the material that we'll use. So I will go to the bottom and I will activate the component. I will sketch on the bottom of it and I will use the offset to create an -8 mm offset. Okay, and I can extrude it. In this part, we'll still have this side for the sliding, but if I will extrude this, the connection, the holder for the crank will disappear. So I will continue with a spline and I will create some part that will still keep the connection for the crank. So I will extrude only this one, but I will finish the sketch. I will rename the sketch. Okay, and let's see how the extrusion will work. I will extrude the same size as the holder, so -4 millimeters. And I will look clearly that I have here a little bit problem, but it will be fixed very, very fast. Those are like levitating. So I will use press and pull to bring them. Okay. I will use then extrusion to bring them on the plate. Awesome. Well, now we have few material and the same purpose of it. Well, we can continue by removing material from the crank as well, material from the slider, but this is enough for this video. You can create your own ideas to remove the extra material. Now we can add the appearance. I'll use the same color code. And the second thing that I want to tell you about the appearance is that by adding the appearance, you can see that you combine correctly the objects. So the pin is correctly combined with the slider. The same thing for the crank and the same thing for the holder. This pin is joined with the holder. Okay, well, now we are ready to add the joints. So in the next video, in the last video, the last mechanism, we enabled the contact sets. Well, Fusion community advise us not to use contact sets when we can use as-built joints instead, because they are more, tedious and they are very delicate. So we will add 4 joints for as-built joints because our components are in place. So one revolute joint between the crank and the holder. This is happening because I didn't ground the holder and it needs to be grounded because it will not move around in the mechanism. As-built joint between the connecting rod. Sorry, the holder was already selected, so I will try again. As-built joint, connecting rod, and crank. Awesome. Now, as-built joint between the slider and the connecting rod. Okay, and as-built joint between slider and the holder. Okay, and now is the moment of truth to see if our mechanism works. And, well, it works very well. Awesome. Wonderful. Okay, well, let's go back then with the angles and let's create a motion study. This one needs to be powered. Let's imagine this one will be powered by a motor. I'll add the last step. I will select the speed and I will click play. And as you can see, our mechanism works very, very well. I can change the speed. Let's see how it works. And it's still going very good. Let's see other speed. Wonderful. So yeah, let's go to a normal speed. And well, that was the crank slider mechanism. The next thing to do will be to 3D print them. But don't forget, when you are 3D printing the mechanism, you will need each component to be saved as a different STL and then assembled in real life. Well, see you into the next videos.